All right, hello and welcome to 1.1 Moles and Molar Mass, our first topic in AP Chemistry. Before I get into this though, I just kind of want to briefly overview some of the things you're going to be using in class. These are the AP Chemistry equations and constants. You will have this on every test and quiz that I give. You will also have the official AP periodic tables. Notice how none of them have the names, so you need to start making sure you know the names of the more common elements. Now, these are for tests and quizzes. If you took me before or took a class where you got a chemistry helper, you are more than welcome to use that. I will also have these in my class and some extra chemistry helpers. So this will be available to you. You can use this on any homework or in-class work that we do. Okay, so I just wanted to go over that briefly with you on the first video so you're aware of what you're going to be using in class. All right, so let's get into it. So if you've taken chemistry before, moles and molar mass is typically associated with stoichiometry. And stoichiometry is, well, in honors and regular chemistry here at this school is Unit 7, second semester. So molar mass is introduced typically in Unit 6 and used in Unit 7 as well. So AP has their own labels for stuff, so always check the equations. So here we have N equals a little m over capital M that looks italicized. N is the moles, M is the mass, and the capital M italicized is molar mass. You might also see MM or M.M. MM also stands for millimeters, so you have to take into account what you're looking at. Now, I'm not going to go over the notes and read them word for word. Basically, I'm going to highlight the big ideas that you need to know. If you don't remember how to calculate molar mass, here are the steps. Here is an example for you. You have to remember how to count the number of atoms of each element in a formula and times that by its mass, and then you are adding all the masses together to get the overall molar mass. Now, there's two ways of writing that. You can write it the short form like this, or you can say 1 mole of N2O4 equals 92.02 grams of N2O4. That's kind of the long way to do it. All right. Now, the next part of the notes is talking about Avogadro's number and how to use Avogadro's number. But use your stoich map from honors and regular chemistry is what I added here, because this is actually just one slice of the stoichiometric map. Now, what is the stoichiometric map? Well, if you took me, I handed this out in a packet in Unit 7. So I'm gonna move this out of the way, and what I would do is I would pause the video and make sure you get this down. Now, why are there all these arrows? There's all these arrows because if you cut the map in half and you're just dealing with one substance, then you can go from moles to particles by using the lighter arrow. If you have particles, you can use the darker arrow and go to moles. So in stoichiometry, when we're dealing with two different substances and we're using the balanced chemical equation, we typically follow the dark arrows, the thicker arrows. If we're doing one substance, we can use both. So in your practice, you're going to mostly be using one side, but there is somewhere you might start at particles of a substance and want to go to moles of another substance. So I'm going to leave this here and just pause the video so you can copy that into your notes. Okay, let me zoom out and get back to 1.1. So really, that's all the notes. You need to know how to calculate molar mass, and you need the stoichiometric map. So let's do the I do and the we do. So normally what I do in these videos is I will go over and do the I do and the we do, and then you do the you do's as homework. Then I go over them in class and give out the key, or I make a video with the key. Since I don't know which one I'm going to do first, I'm going to leave you to do the you do's on your own, and I will get with you later on the key. Now with the you do's, to try to keep it to as little as much paper, and to kind of try to save paper, you may have to do some of these math problems on a separate piece of paper and just put your answers here. I also will review these with you and kind of give you clues on how to solve them, but I won't set them up for you. Okay? All right, now on a separate paper, I went ahead and did the I do and the we do. Now you can also watch the video. If you pull up your camera and you put it right over this, it will take you to a Dropbox or a YouTube video. You are more than welcome to watch those. However, she did this a little bit differently than what I did, and my method has less steps, but please feel free to watch the video. Something might click with you and that makes more sense for you. So I'm just going to briefly run down the math. So whenever you have a problem, you want to identify your given and your unknown. And because we started with 25 grams of the sample, and the sample is lead 2 iodide, and we want to get to moles of lead 2 iodide. So we're just dealing with one substance going from mass to moles. So I always identify the given in green and the unknown in yellow. I put the given over 1. That's my first step. And then I typically do molar mass in blue. So 1 mole of lead iodide is the molar mass of lead iodide. So 1 lead and 2 iodines is 461. So when you multiply across the top, multiply across the bottom, and then divide, you get this answer. So that's called dimensional analysis. It's setting up fractional math and plugging in the numbers and doing it. So here, instead of going back to the 25 grams and figuring out atoms, I just used the answer from here and went from moles of 1 mole of lead 2 iodide is 1 mole lead. Where did I get that 1 mole lead? Well, there's only 1 lead in the formula. There's 2 iodines. So if this said what are the number of atoms of iodine, then I would have to put 2 moles of iodine here to 1 mole of lead 2 iodine. Get rid of the moles of lead 2 iodine. I have moles of lead. I don't want moles of lead. I want atoms of lead. So 1 mole of lead is Avogadro's number in atoms of lead. So you can see the red canceling the units, leaving me with the units I want. And when I multiply across the top and then divide by 1, which is the same number, I get 3.27 times 10 to the 22nd atoms of lead. Okay. For the we do, we have to find the molar mass of calcium carbonate first. So we take our grams of calcium carbonate over 1. Our molar mass, 1 mole of anything is its molar mass, so that's the mass of calcium carbonate. And it says formula units. Do not abbreviate formula units to F dot U dot. Put FOR dot and then unit. So 1 mole of calcium carbonate is the formula unit, Avogadro's number of formula units. When I multiply across the top, multiply across the bottom, and then divide, I get 1.47 times 10 to the 21st formula units of calcium carbonate. All right, so briefly, how do we do the U-dos? Well, you're using the stoichiometric map, and you're going from grams of methane to moles of methane. How many particles of methane? So you're going to take the answer of this, and you're going to have moles, and you want to go to particles. So essentially, let me get my map here. You're starting at grams. You're going to go to moles by using this, and then you're going to go to particles by using this formula, the skinny arrow, to get to particles. And in your map, you want to put particles, formula units, atoms, molecules. Those are all the units when you use Avogadro's number. It just depends on what compound or element you're working with. All right, number 2 again is stoichiometric. If you have 150 grams, how many atoms of helium are used? So you're going to go from grams of helium to atoms of helium. If you know the mass and identity of a sample, what other information would you need? Well, to get the atoms, look at your stoichiometric map. If you know the molar mass, you know the mass of the element, what else would you have to know from the map to answer number 3? Number 4, you have lithium chloride, lithium bromide, lithium fluoride, and lithium iodide. Place them in order of least to greatest number of atoms of lithium. They're all 10 grams. You got to convert that 10 grams of lithium chloride into atoms of lithium chloride. Okay, so think of the molar mass. Probably the higher the molar mass, the less of the percent of lithium atoms to the other nonmetal there's going to be. What is the mass of one atom of carbon-12? Well, that's not the mass of carbon. 1 mole of anything is the mass of an element. But this is saying atom, so be careful with this. You got to set this up as you've got 12 grams of carbon. You got to get to atoms of carbon. Okay. And then here, what is the mass if I start with particles of water? So you want to take this particles number of water and turn it into mass of water. So just follow, again, your stoichiometric map. And then number 7, what is greater, this many moles of carbon dioxide or this many particles of carbon monoxide? Well, you got to take the moles of carbon dioxide and get them into mass of carbon dioxide. And then here you got to go from particles to moles, then to mass of carbon monoxide to see which one has the higher mass. All right, so that is the review of the I Do, We Do and how to do the other problems, and then the review of the notes. And I will see you in class.